Yeah, please.
Okay, maybe I will opening first. Good afternoon to all participants. Assalamualaikum warahmatullahi wabarakatuh. Dear
Waalaikumsalam.
guests, students, and participants, it is a great pleasure to welcome you all to the International Lecture Series 9, year 2025. I am Nimas Larasati, and I am delighted to have the opportunity to host this special occasion. And we are delighted to have all of you here at this event today, which will discuss inclusive remote sensing for urban and regional planning. Firstly, I would like to welcome Dr. Yudi Basuki, the head of the Bachelor Program of Urban and Regional Planning Department. Allow me to extend to our warmest gratitude to our honorable guest lecturer, Mustafa Ustuner, PhD. He will be the first speaker for today's session. And next, we have Ibu Sri Rahayu, M.Si, as the second speaker, and Bapak Widjonarko, M.T, as the moderator. Before we proceed to the main event, please review the event agenda for today. Okay, this is the rundown for today. The first is opening by M.Si, and then opening remarks from Head of Bachelor Department of Urban and Regional Planning, Dr. Yudi Basuki, STMT, and then the first lecture, and the next is the first lecture is about synthetic aperture radar, or SAR, implementation to advance remote sensing, and then the second lecture is application of remote sensing and GIS to estimate above ground carbon stock change, and then discussion and conclusion, and the last is closing with photo session. Okay, let us hear the opening speech from the head of the Bachelor Program of Urban and Regional Planning Department, Dr. Yudi Basuki. The time is yours.
Thank you, Nimas. Okay, good afternoon, everybody. Assalamualaikum warahmatullahi wabarakatuh. Welcome, Mustafa, to our country, although it's online. So, welcome to International Lecture Series. I think it's the 9th series, yeah, during the 2025, yeah. So I'm as a representative of the Urban and Regional Planning Department. I'm very honored to have Mustafa Ustuner, PhD, and Rahayu or Sri Rahayu, M.Si, as the speakers of the today lecture. Yeah. So I think it's a very interesting topic to geometric laboratory. Yeah. And yeah, it's related to yeah, our country. Yeah. Our country is not in a well condition, Mustafa. There is some disaster, yeah, in Banda Aceh, in North Sumatra, and West Sumatra, yeah. So I hope this discussion can bring us about the knowledge to overcome or to mitigation the disaster, yeah. So I urge to all of you participants to sit back, relax, but focus to absorb the information that will be shared today. Yeah? I think it promises to be an insightful and enrichment experience for all us today. Yeah? Maybe you can use it for your project, final project, or I think there's some practitioner in here, so you can yeah, many advantages to this discussion. Yeah. So last but not least, I would also like to take a moment to express our gratitude to the organizer who have made this lecture possible. Yeah, Bulandung, Bulani, and every Mas Imam, yeah, and friend, yeah, and the team, yeah. So thank you for coming and enjoy the 9 ELS. And yeah, thank you very much once again for Mustafa. We are honored to having you here. Yeah. Thank you. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Dr. Yudi Basuki, for the warm welcoming remark. So let us get started and welcome Bapak Widjonarko MT as a moderator. For Pak Koko, the room is yours.
Oke, thank you Mbak Nima. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, all participants. It is my honor to welcome you to this international lecture series on a topic that has become increasingly vital to our self-future. And we have a topic about the synthetic aperture radar, or SAR, in climate monitoring and carbon stock monitoring. And do you know that the advance of in remote sensing technology make it easier for us to better manage natural resources, including environmental management? To answer this question, two highly competent experts are present in this Zoom meeting in international lecture series to present their research and their finding on remote sensing technology and its use for environmental monitoring. We would like to introduce the first presenter, Mrs. Rahayu, Sri Rahayu, who will discuss about the remote sensing and GIS application for carbon stock monitoring. And please, Mbak Lani, you can share the CV of Mrs. Sri Rahayu. Okay, Mrs. Rahayu is the lecturer in Department of Urban and Regional Planning. His expertise in remote sensing technology and environmental management. He has so many research projects from the first years she was in Department of Urban and Regional Planning until now, and he is known as the one of the researcher who has a certificate on uh, strategic environmental analysis. Mrs. Rahayu will present their research on monitoring above ground carbon stock using remote sensing and GIS. And then the second presenter is Mr. Mustafa Ustuner. Balani, you can. Okay, this is Mr. Mustafa Ustuner, PhD. He has a very many experience in this project, as Mr. Yudi Basuki mentioned before. And there is a project is run from 2005 until now, and his expertise is about the uh, remote sensing and application on managing the satellite imagery, including the SAR data. Okay, for the next presentation, maybe Mrs. Rahayu, Mrs. Rahayu, you can share your screen to present your research on monitoring above ground carbon stock using remote sensing and GIS. Sorry, I change the presenter because we have the lady, so we have to make the lady special. So we have to make ladies first to present their research. Please, Mrs. Rahayu. You have 15 minutes to present your research, and then will be continued by Mr. Mustafa also for 15 minutes. Then the after the presentation of those presenters, uh, all of the student or all participants, maybe you can discuss, you can ask, or you can uh, clarify about the research that has been held by Mrs. Rahayu or by Mr. Mustafa. Okay, take your time, Bu Sri Rahayu, for 15 minutes. Oh, sorry, the presentation will be 30 to 40 minutes. So, Mrs. Sri Rahayu, you can use your time 30 to 40 minutes, and then Mr. Mustafa will continue the presentation. Sorry for this information.
Okay. Thank you, Mr. Widjonarko for the times. Good afternoon, everybody, and welcome to my presentation. Okay, the topics my presentation is of. Okay, the topic my presentation is of application of remote sensing. Application of remote sensing and GIS to estimates above ground carbon stock change. Okay, maybe we know today yes, climate change is one of the greatest challenge of our times. Talking about climate change cannot be separated from urbanization and city, and one of the impact of urbanization is change lands coverage. Urbanization, climate change, and city are closely interrelated because change in one aspect will affect the others. Okay, uncontrolled urbanization in Indonesia, especially in Java, has resulted in environmental degradation occurring very rapidly. Okay, vegetated lands such as forest and green space has the important function to support urban ecosystem service by contributes store carbon. Change in land cover naturally impacts the amount of carbon stored in terrestrial vegetation. The greater the extent of deforestation and forest degradation, the greater the reduction in carbon reserve. The change of vegetated land to build up land can affect above ground carbon stocks and have an impact on greenhouse gas emission in an area. Greenhouse gas emission can cause global warming and climate change. Okay, why we use remote sensing to estimate above ground carbon stock chain? Maybe many ration here, and in here in this is we use remote sensing to estimate above ground carbon stock chain because in remote sensing data can have large areal coverage, and remote sensing data faster land cover in an area can be identified using satellite imagery data and analyzed with GIS. And based on land cover data, it is possible to estimate above ground carbon stock. So with remote sensing, we detect object with device. Device is sensor. Okay, and here I give example application of remote sensing and GIS to estimate above ground carbon stock change to support sustainable development. A case study of Mijen Subdistrict, Semarang City. Okay, maybe we know Mijen Subdistrict. Mijen Subdistrict is one of the suburban area which affected by development of Semarang City, which has experienced massive physical development. You can see in here. This is Mijen Subdistrict. Yeah, it's divided by this Felicia is in here. You can is a picture my maps. Yeah. Okay, this will have an impact of change in land cover, especially vegetated land cover to build up land to accommodate the increasing population activity. So according to the spatial planning of Semarang City, for 2011 until 2031, Mijen Subdistrict is part of the city region 9, which the main function as an area for the development of the city launch. Okay, in my example here, I use two image. This image is sentinel imagery. This is record in 2017, and sentinel image record in 2022. Okay, from image, you can in here step by step in my analysis from Sentinel to in here. In first steps is image pre-processing. This image pre-processing divided into step. This is geometric correction and radiometric correction. So then pen composite, and from sentinel image, that is visual interpretation, and this is from my interpretation, is product is land cover in Mijen Subdistricts, the 2017, and land cover Mijen Subdistrict 2022. Okay, based on land cover data, it is possible to estimate above ground carbon stock, and this you can see in here. This from this study was conducted to obtain of overview change in above ground carbon stock in Mijen Subdistricts during 2017 until 2022 using satellite imagery data and analysis with GIS. Okay. So after image interpretation to calculate carbon stock, I use standard carbon stock based on land cover. You can see in here standard of carbon stock. Yeah. In here, my land cover divided 7 land cover. This land cover is plantation forest, built up land, open land, for dry and agriculture, 6 mixed dry and agriculture, paddy field, and water body. Okay, this land cover have different carbon stock. Example, in here, plantation forest have 98 ton carbon per hectare. Built up land have 4 ton carbon per hectare. Open land more or less 2.5 carbon ton per hectare. And example, mixed dry land agriculture have 30 ton carbon per hectare. Okay, to estimate of above ground carbon stock based on land conversation, I use a formula. This formula you can see in my screen. This formula is delta C equal the carbon stock of X pull out beginning minus this carbon stock X pull at the end divided by the times time the end minus time the start. Okay, so from my calculator and my presentation, you can see in here result my presentation, my interpretation. And here I need to land cover map. This is map land cover Midjen subdistrict in 2017, and this is land cover in mid of a Midjen subdistrict in 2022. Okay, from overlay land cover of Midjen subdistrict 2017 and 2022, as I get change of land cover. Okay, land cover, change of area and change of land cover emission subdistricts. You can see in my table. From my table, you can see example plantation forest during 2017 until 2022. Area of change is degree 3.63 hectare. Okay, dryland agriculture area of change degree, and you can see in here 153 hectare, and maybe is the higher in here. Area of change is built up land in this year. You can see area of change is 329 hectare during 2017 until 2022. Okay, so from my map and from my table, so we can talk land cover change, indicate land cover change in Midjen subdistrict indicates that a conversion of vegetated land to build up land are quickly. Okay, so and the other you can see in here my calculate to change above ground carbon. Okay, so from the table you can see above change above ground carbon stock from land cover. Yeah, example from land cover plantation forest in here change during change 2017 until 2022 is the decrease, and decrease 360 350 220 eggs 256 ton total tons. Yeah. Okay. You can see another change of above ground carbon stock in here. Overall carbon stock decrease by 300 to by 3,234 ton carbon. It means annual change is in carbon stock decrease by 646 ton carbon. Okay, from this here you can see, and here the result indicates that upper and Midjen district will experience declines in a green status. This can explain the environmental impact of urban expansion to suburban. Okay, this the presence of vegetation in urban area makes major contributes to reduce the negative impact of urban activity and improving environmental quality, including improving air quality, energy conservation, reduction air temperature, and ultraviolet radiation. So, measuring of carbon storage by urban forests is very important, as section is the role of trees in reducing carbon dioxide and concentration and moderating temperature in the urban area. Okay. Okay, from here, my to conclude, I like to say increasing build up land and reduce vegetated land can reduce carbon stocks. Second, change from land cover with high carbon stock to land cover types with low carbon stock cause a large amount of carbon loss. Okay, rapid growth of built-up land in Midland subdistricts, especially for settlement, is affected by Semarang city development. Land cover change will continue in the future and become a challenge for policymakers to make Midland districts the launch of Semarang city. Okay, I think enough from me. Thank you very much for your extension. Okay. And the times to Mr. Widjonarko.
Thank you, Bu Yayu, for your interesting and comprehensive presentation. And it's very interesting. Mijen, the peripheral of Semarang city has been growth as a new housing area, and by research by Ms. Yayu proved that the land cover change has implicated to the decrease of carbon stock in periphery of Semarang city. Okay, for the next presentation, Mr. Mustafa, you can continue for the second topic, the use of SAR to advance remote sensing. Please, your time, Mr. Mustafa.
Okay, thank you. Can you hear me?
Yes, clearly, Mr. Mustafa.
Great. First, I need to let me just a second here. And just a second, I want to share a video, but I'm not sure how. Here. So can you see a video right now here?
Yes, your presentation is on screen.
The utilization of Earth observation satellite technologies is on the rise, with an increasing number of entities leveraging satellite imagery for enhanced global insights and monitoring of changes. Despite its benefits, optical satellite systems face challenges, such as cloud cover and nighttime limitations, which can hinder their effectiveness during critical events like natural disasters. To overcome these obstacles, synthetic aperture radar offers a powerful alternative. Radar satellites emit radar waves that map the Earth's surface by capturing the reflected signals, enabling them to penetrate clouds, see beneath canopies, and operate in all weather conditions. This capability has spurred growth in the SAR segment of the new space movement, attracting significant investment and innovation. Companies like Capella Space and SpaceD have raised substantial funds, contributing to the rapid expansion and accessibility of SAR data and analytics. Radar imagery, known for its ability to produce images under any weather conditions and time, differs significantly from optical data. These images capture the backscatter signal rather than the direct appearance of objects, making them challenging for human interpretation without processing. This has led to a reliance on algorithms and machine learning for data extraction, with companies often providing processed information rather than raw data to clients. This market has seen notable growth driven by its critical role in emergency responses. With a projected increase in global revenues, radar technology is critical for strategic operations. Despite the dominance of large operated by government satellites, startups are making strides with micro-satellite constellations, offering high-quality data at lower costs and fostering new applications. The development of radar has been marked by significant milestones, including the launch of commercial satellites and the provision of free data by missions like Sentinel-1. This evolution reflects a shift towards smaller, cost-effective satellites and a growing ecosystem of applications ranging from emergency management to agriculture. As radar technology continues to evolve, the industry faces challenges in data accessibility, processing, and analysis. However, initiatives to democratize this data and simplify its analysis are underway, promising to broaden its application and impact. Learn more from original paper about radar's unique capabilities, the future of Earth observation.
So I will share my presentation here. Just a second. Let me share the full screen first. It's here. And then, yes. So can you see my screen here?
Yes.
The full screen, right?
Yes, it's clear.
Great. So hello everyone, and thank you so much for inviting me to this lecture series. And I'm really glad to share some part of my research with you here, and I hope you will enjoy listening my talk. I will try to keep it as simple as possible because when, in general, SAR remote sensing is a little bit sometimes classified as the advanced topic in remote sensing. Therefore, when you go into the details, sometimes people don't want to actually listen. Therefore, I try to keep it as simple as possible and show you some example of some toolbox and data processing, how we can process the SAR data. So before start my talk, I would like to quickly introduce myself. I'm currently working as an assistant professor at the Department of Climate Science and Meteorological Engineering. And during my master and PhD, I was in University of South Florida and Friedrich University of Vienna in Germany. In general, I work with polarimetric centric aperture radar data. At the same time, work with hyperspectral and multispectral data along with machine learning, dimension reduction, and currently right now working with large language models in general. So, and in today's lecture, I try to give you some overview of centric aperture radar, polarimetric SAR, which is an advanced, not advanced, a different type of centric aperture radar data, and just a quick example of SAR for crop mapping and monitoring, and just quick example of some data processing steps. So this is actually how radar or SAR image look like. I will talk about like HH, HV, and VH channels of SAR data. So when we look at these two image, the one is from Istanbul, Turkey. The other one is Leipzig from Germany. And this is the pre-processed data, which means the original SAR data not actually look like that. After some processing, we can see the images, the Earth observation images, something like that. As you could see here, this is something different than the natural image. Like even though the forest area looks green, but some other areas is something unnatural color. We call it false color in SAR remote sensing. These are two images. One, in terms of the polarimetric SAR image. Both are from ALOS 2 data, which is the Japanese satellite, SAR satellite in L-band. And in the images, the colors represent scattering mechanism, not the actual color that human eye recognize. Not like for instance, when you look at the sky or look at the sea, you can see the color blue, but in that image, it is not the actual color because of the microwave region of the electromagnetic spectrum. So this is actually how optical and radar remote sensing differs from each other. And this is the part of the electromagnetic spectrum. The radar sensors works and operates in the microwave region, and the optical sensors like the multifocal sensors in the visible region. So what is radar? Radar means actually radio detection and ranging. It means it's sending the signals to the object and receiving back. We call it backscatter to the system. So how it works? As you can see from these 2 or 3 images, the radar sending signals to the target, and from the target it backs to the radar system. We call it backscatter. It's also called reflected echo. So this is just an example how radar works. So why we call it centric aperture radar? What does it mean? Okay, first radar is the side-looking geometry, which means we, at the original SAR system, we don't have the square pixel. Therefore, we have 2 different resolution. The one is range resolution, the other one is the azimuth resolution. Okay, in SAR system, normally the antenna is short, and this antenna is artificially elongated by using some techniques, and which makes the antenna artificially longer than the than the original version. Before starting SAR imaging, we need to understand the geometry of the SAR sensors, which has side-looking geometry. Therefore, it has 2 types of resolution, range and azimuth resolution. Because of the microwave region, we have 2 different information, which means phase and amplitude information, and different side-looking geometry and different mode acquisition, where I will go into some details like single look complex and multi-look images. And in different frequency, we need several bands on it. So this is actually how image look like, the slant range and ground range as the 2 type of resolution. And this is actually how radar, at first, while explaining the resolution and imaging type, we are using airborne system at first. Here, the imaging geometry. C is SWAT, E is range, E is azimuth direction, and D is azimuth direction, E is the flight direction here. This is a typical imaging geometry of SARS sensors. Yeah, here is better visualization of the resolution. In that case, we call it theta angle here. It is important because of the resolution, understanding the resolution of the image. It is called look angle. And this is kind of the boring part, the phase and amplitude information. It's more about coming from the signal processing, but we can understand the amplitude information comes from the intensity of the signal, and the phase information is also a real and imaginary part of the complex signal, the SAR signal. This is actually how it looks like in real imaging of SAR. Of course, to understand or to able to use the SAR data, we are process the raw data to get the image analyzed ready data, at least in terms of remote sensing. So this is actually how SAR image look like. This is a type of the complex image, the amplitude and intensity. And when we look at the here, you can see that the original pixel is not secure. And we multiply, it's called the multi-looking processing, to get the secure pixel, like the average value of this 4 pixel to get the secure pixel. Because of the imaging geometry, as I explained, we cannot get the original secure pixel, but there are some steps to get the secure pixel for that. This is actually how raw data, how original radar data or SAR image looks like. After some signal processing techniques, we can get the kind of black and white SAR black and white image, which is the processed SAR image. Again, this is how original SAR data look like. After processing the data, we get the single channel of SAR images. And when we talk about the polarimetry and interferometry, which uses the multi-channel of the single channel of SAR images here. As I explained or explained before, okay, not much in detail because SAR processing steps need some expertise to understand. Therefore, every processing step has some details, but I will not go into such details to get the overview of SAR data processing. This is how, depending on the look angle and the sweat width, there are 3 types of acquisition mode: street map, scanner, and spotlight. And let's jump into the radar polarimetry. What does it mean? It means polarimetry means polarization and measure of the signal. In that case, SAR signal could be vertical, horizontal, and circular in third type. And the latest satellite launched by the joint work of the NASA and Indian Space Organization. The name of the satellite is NISAR, and this is just an example of a circular polarization. So, what does it mean? Okay, in radar polarimetry, there are 3 types of polarization acquisition available. They are single, dual, and 4 polarization, which means when we talk about the radar polarimetry, we must use quad polarization, the 4 polarization. You can see how HH and vertical and horizontal signals of the SAR systems looks like. And the backscatter information is important in SAR remote sensing, depending on which wavelength you are using. If you are using, for instance, the X band, it backscatter from the top of the surface, for instance, and C band and L band is a little bit penetrate to the object, and P band is nearly coming to the surface of the object. Therefore, while choosing the frequency of the SAR imaging or SAR satellite, we are focusing on which object we need to focus on or understand. For instance, if you are working with agricultural areas, you can use C-band. If you're, for instance, working with the urban areas and some, for instance, land change, you can use X-band. If you are working with the, for instance, the forestry data or forest areas, L-band could be more proper in terms of each of them have different penetration capabilities depending of the wavelength information. This is how emitters looks like. For instance, for the same area, but in a different wavelength information, you can see the L-band for the same area looks a little bit darker because of the stronger penetration. This is also another example how it looks like. And this, as I already mentioned, the scattering is also the important phenomena in radar polarimetry, because each target could have different scattering mechanism. For instance, it's the rough surface here, it's the deterministic scattering for forestry, and for urban areas, we can say like volume scattering and double band scattering, which help us to characterize the object from the SAR image. Okay, this is another example how the radar signal interacts with the surface and coming back to the satellite. Let's see, and for instance, for water or surface areas, it is the rough scattering. For volumic, the forest area, it has volumetric scattering. And this is how SAR image look like. In the optical image and the SAR image, there is no cloud. It obtained image day and night and weather independent, and the style looking geometry. So let's talk about a little bit more about SAR for agriculture. In essence, in SAR agriculture, these three types of scattering could be available depending on the structure of the agricultural or the crops. You can see the surface scattering, volume scattering, and double band scattering, depending on the structure of the crops. So why SAR is important for agriculture? Because SAR signals are sensitive, of course, not only for agriculture, also for urban areas, also for forest areas, depending on the wavelength. And SAR signals are sensitive to be honest, these targets in the Earth's surface. Because of the dielectric properties, SAR signal could be very useful in terms of understanding the Earth's surface targets. This is actually another example how SAR signals sending and receiving back to the target, depending on the structure and the physical properties of the object. This is another example how this is an typical example. Is a little bit old example, but a good example to show how radar image process data looks like depending on the different crop types in the SAR image. This is also another special plot of how radar signal changes depending on the growing phase of the crops. You can see the backscatter information in the decibel scale, the products, and the SAR signal are changing. Okay, we can skip this part because we already talked about the SAR polarimetry, but just to say that the original signal is the backscatter signal and NO. And when we try to understand the scattering mechanism, we convert this data into covariance and coherence matrices. And after this covariance and coherence matrices, we can extract the linear polarization. And okay, these are the formulas. But no worry about the formula because there are some tools to generate such features. Okay, and okay, for target decomposition, we generate this decomposition by using these two matrices, covariance and coherence matrices. But how? Okay, these are my papers from the radar polarimetry and SAR in general. Actually, this is my PhD thesis. So, okay, when we look at this, okay, that part could be a little bit boring, but I will try to make it as simple as possible. Okay, there are two types of decomposition methods which help us to understand and interpret the complex SAR data for better interpretation. For instance, the eigenvector-based decomposition uses the T matrix. The model-based decomposition uses the C matrix, the covariance and coherence matrices. So this is the Claude-Potter decomposition. It's based on the coherence matrix, the decomposition of coherence matrix. At the end, it provides us three output, the entropy, anisotropy, and mean alpha angle. Another example is the Freeman-Jordan decomposition. It directly gives us the scattering mechanism, single bounds. This is the total scattering. But based on the decomposition of the covariance matrix, it provides us the three components, like here. And for instance, this process data, when we apply the, for instance, Claude-Potter decomposition, it provides us three outputs, like entropy, and mean alpha angle, as you could see here. So let's see what type of software and toolbox. Oh, just a second. I can share once again. Sorry for, yeah, here. Okay, can you see my screen, right?
Yes, Mr. Mustafa.
Great. I will just give you some common software and toolbox for SAR remote sensing. These are the example of Snap software, which is freely available. It has graphical user interface. You can process your SAR data. At the same time, there are also another software, Pulsar Pro, which Snap and Pulsar Pro are freely available, downloaded by ESA website. Another software is ASF MapReady, available also for Alaska Satellite Facility website. You can download and process your SAR data for free and easily available. And in terms of a little bit more about the scientific processing, you can also use some Python libraries, the R libraries. And to automate your SAR processing, you can also use some libraries like Pyrosar, which is developed by the German researchers in University of Vienna, where I was a PhD researcher in that research group. So you can also check these libraries in terms of understanding and processing the SAR data in the automated workflow. So let's just show you a quick example in the Python environment, but I just copied and pasted my codes in terms of saving the data. So this is just a quick example. From the Jupyter Notebook, which is a area where you can run your Python codes. I just get the print screen of the code because it takes some time to run the codes. Therefore, I just try to explain how it works. First, it's import the required libraries in terms of processing the SAR data. And in terms of this is just the calculating the radar vision index from Sentinel-1 data. At first, it connects to the data space Copernicus EU, where you can download the data. Here is the DRD, is the ground range detection data. I just choose the data and some details like which months, which temporal resolution of the data, not the resolution, but the time domain of the data. And it's basically process the data in SAR backscatter, and the RVI is the formula of the reservation index here, like 4 multiply VH divide VV plus VH, and in that code it's download the data. To be able to saving the time, I just not running the codes live here, but showing you how it works. And then after downloading the data, we just visualize it here. This is how radiation index data from Center 1 looks like, and the backscatter information based on the time series. So thank you so much. I hope I was okay with the timing.
Okay, thank you, Mr. Mustafa. It is sharp 30 minutes from your presentation. Thank you for your comprehensive and detailed presentation on SAR data from
Yeah,
the
thanks so
data
much.
acquisition process, the radar to capture any object on Earth surfaces, and to its use in agriculture or to detect urban change area. And you explained that the SAR data can penetrate the cloud cover, so it gives better information on Earth surfaces because we often disturbed by the cloud cover when using the Sentinel, not Sentinel using SAR Landsat data. Some cloud cover maybe will disrupt the information on satellite imagery. And one of the interesting point is that Mr. Mustafa offered us and various software that can be used for SAR data processing. And we appreciate for your presentation. It's very remarkable, and maybe it will make the student more anxious to learn about the satellite data processing using remote sensing approach and GIS. Thank you for your presentation, Mr. Mustafa. And this is Yayu. Maybe in the second session, all participants are welcome to ask question or respond the presentation by both presenters. Please welcome. Maybe in the first session, I will give 5 students to ask Mr. Mustafa or to ask Mrs. Yayu for their research. Please, 5 students or 5 participants. Maybe you can ask in Bahasa or ask in English. I will have to translate your.
Bahasa Indonesia, it's okay.
Okay, thank you, Mr. Anang.
Okay, for opening this discussion, thank you, Bu Yayu and Mustafa, for this interesting material. And I guess for Mustafa, can you give us the comparison of the advantages in using SAR? Because we know, like Pak Widjonarko said, that using SAR data is avoid the cloud cover, and then what about in detail analysis? Yeah, for example, we often using the optical remote sensing data, then radar data. So, what the advantages if we using the SAR data, especially in urban analysis? Maybe you can explain it, Mustafa. Thank you.
Yeah, thank you so much for this good question. First, SAR signal penetrate clouds, which means if, for instance, your city or your country has a especially for summer term or like the winter term, has for instance, the high cloud coverage. For radar, it is not a problem at all, which means it can get the. I will just talk about for urban analysis at first. First, the cloud is not a problem. The second is, especially for X-band, mostly available for the German satellite, TerraSat X, maybe some other high-resolution satellite available from the private companies, like Capella Space or some other S.Si from maybe some other companies in Japan, I'm not sure. But by using the X-band, it provides us the different characteristics of the urban areas, especially for depending on the roof types, for instance, or the materials of the object. When we look at these type of Earth targets, the optical sensors, I mean like the multispectral sensor, for instance, support Landsat Sentinel-2 or some other high-resolution sensors like WebView 2 or like such sensors. Okay, of course, it provides us the high-resolution data or like the medium-resolution data, but in the optical region, which means in the visible region. But after, when you combine the SAR signal, okay, when we look at this image, okay, there is no cloud. But in terms of the characteristic of the surface, like the material of the buildings, of the urban areas, like some roads, some other human-made or man-made object, starting to provide us different characteristics, which we cannot extract such details from the optical data. So what my suggestion is at first, okay, the optical sensors, like the multispectral sensors, looks more, how can I say, fantastic compared to SAR sensor because of the natural color advantage. But when you combine with optical sensors, it provides us more information to extract some specific details. Like it's for instance, when you distinguish, for instance, the roads from the buildings or the airports or some other man-made structure, depending on the scattering information, SAR signals could provide more beneficial information. Just suppose like suburban areas, some detection of the, for instance, the old building or like for instance, such things, it could have different backscatter information. In some case, it provides the complementary details to the optical sensors. So from my case, when I, of course, depending on the backscattering information, when I work with the, for instance, the urban areas, at first I check, of course, the optical images, that how the buildings of areas looks like. But since resolution is not enough, for instance, for Landsat or for support like such things, SAR sensor could provide the complementary information depending, of course, of the wavelength or frequency of the data, but it provides the very beneficial information to the optical sensors. And when we look at the broad view of the, for instance, in terms of the planning, like city planning or urban planning, it provides also the great information.
Okay, that's all. Okay,
So
yang
another
lain?
question?
Thank you, Pak Anang. Thank you, Pak
Yeah.
Mustafa, for your explanation. Maybe all of us are the end user of satellite imagery. And perhaps some of us don't really care about how the imagery is created. They're more interested in obtaining free data of satellite imagery that can be processed according to their analysis need. And This is my question. Maybe it will represent most of the participants. Mr. Mustafa, can you explain the source of SAR image data that can be accessed quickly and for free? This is the first question.
Yeah.
And the second question, is the software that you develop can offer us how to process the data for agricultural crop productivity measuring or to detect urban change area. So or to monitor any environmental problem in a given area.
Mhm. Okay, let me share my screen here at first to show quickly. Okay, to your first question, and I would suggest the European Space Agency provided toolbox and freely available Sentinel-1 image. At the first step, this is just an example, some basic tutorials, for instance, how to download the data, how to process the data, which step you have to follow to, for instance, get the original image. And here is, let me show you, like the terrain corrected, I mean the final image in the decibel scale, for instance. So I would suggest if anyone jump into the soil remote sensing and try to understand some basics and not go into detail of like the programming and to see the step by step the data processing, I would suggest the snap software. Here is the graphical interface of the snap, which is freely available. When you go into the ESA website, you can download the data at the same time the tutorials freely available. And to your second question, okay, I just show you some example from agriculture. But in terms of SAR data processing, except interpretation for agriculture or for urban areas, the step is somehow similar in terms of data processing and some critical steps in terms of understanding the concept. Like for instance, for agriculture, you can use C-band data, but for urban areas, since the details a little bit sharper, and mostly for the urban areas and building a double bands, you can use X-band data. So if you're working on that area, I would suggest Sentinel-1 at first is C-band, but unfortunately the X-band data, Terrestrial X, is not freely available. But the good point is for educational and research purposes, you can write some research, very short research proposal and submit it to the German Aerospace Center, which is called DLR, and get the data for free. Why I'm saying this information? Because last year I met with the group leader of the Earth observation of the DLR. I just met in Turkey and asked that question, like students or some researchers need to get some TSRX data for research and for educational purposes. How we can get that for free? And she just told me that's something simple. Just go to the website, fill the form, write your research purposes, like very short abstract, how much data you need, and then submit it to our website, and then we can check and send you the data for free, like in general, not something specific for me. It's available for everyone. So
Thank you, Mr. Mustafa. So we just access the ESA website and then log in, and then we can download the data for free. And ESA also offer us the Snap software to process the satellite Sentinel-1 SAR. And also we can use the multispectral index for any purposes in remote sensing data processing.
Yeah,
Okay,
exactly.
any other participants? Maybe you can ask to both Mrs. Sri Rahayu or Mr. Mustafa about the use of remote sensing to detect the environmental change or to detect the carbon stock in a given area.
Maybe if our student cannot propose in English, so in bahasa is okay, Pak Koko. So we can translate it.
Okay,
Uh,
you can use bahasa.
Yeah, guys,
Silakan teman-teman.
don't be shy.
Wait to say maybe.
Yeah,
What
yeah.
about the student in
I'm here for
Turkey?
you.
Is it similar condition when it's already discussed something harder? Maybe that is new for us, and then so hard there because this is very new for my student. So yes, it's normally maybe they can get the new shape to thinking about the SAR for urban planning. So silakan
Yeah.
teman-teman 2025, 2024 silakan kalau mau tanya pakai bahasa Indonesia boleh. Pak Koko siap menjelaskan. Tidak ada Pak Wid. Atau mau chat juga boleh. Silakan ngisi kolom chat pertanyaannya silakan.
Yes, I will be happy to answer any of the question. Yeah, no problem.
Your
Or maybe
first
next
slide
time,
needs
yeah, please.
your first slide need student maybe very it's complicated about the SAR because they usually use this is satellite imagery. We can see the earth surfaces and then we can see the urban change. Not they did not imagine how the uh, earth surfaces object captured by the satellite data. So for them, maybe it's very complicated and it is beyond their imagination.
Yeah. Okay, maybe next time my background comes from, at least from my master, I work with optical data, like for machine learning, like classification with Landsat or like Sentinel-2 data in Python or M.Vi or like ArcGIS. My background also comes from that side, from the geomatics. Maybe next time I can make it a little bit simplify to how to understand the remote sensing data, even for multispectral or hyperspectral, instead of giving the theory, maybe I can show some data processing steps or like the implementation to make remote sensing more attractive for students. I'm not sure about your plan, but for maybe your some other lecture series, I can just show some kind of hands-on tutorials, like how to download the data, how to prepare the data for instance, the urban change detection, and something like that.
Okay, it is maybe more interesting because most of the participants are the new student in urban and regional planning department. So maybe they
Yeah, I
still
understand. No
uh,
problem.
okay. Or maybe you can explain us your experience about using the Sentinel-1 SAR. In example, you can explain how the Sentinel-1 SAR can use to detect the flood in an urban area or in a watershed area. So the student will be have a brief picture about the use of Sentinel-1 SAR in their future works in Urban and Regional Planning Department?
Yeah. First, these are the sensors, at least for Sentinel-1, at least for your research, for urban and regional planning, for city planning, for understanding the urban change, or for flood mapping could be very advantageous compared to optical sensors, because for flood mapping and the water surface are changing, and to understand such changes from source signals could be very easy because the backscatter changes. And along with the optical sensors like Sentinel-2 or Landsat, when you combine these two type of data, which we called multi-sensor data, could be very beneficial and provide us the advantage. Like, for instance, if we cannot find or see some critical details from the optical sensors, we can see such details from SAR sensors because of it operates in the microwave region. So in that case, what should we do is we just rectify, to get the optical sensors with the SAR sensors in the same reference frame, in the same geolocation, and then use SAR data as if as an additional optical data like the spectral bands. And of course, also another topic is maybe a little bit advanced topic, which is called image fusion, or a kind of punch sharpening. We can use our sensors not for punch sharpening, but for image fusion. We can also fuse data. It's a little bit advanced topic, but very useful and proper areas, at least in remote sensing. So for urban change detection or flood mapping, SAR, of course, provides some beneficial information compared to optical sensors.
So if we know about the Sentinel-1 SAR, more we know, more we have beneficial to use it for any thing in urban and regional planning. And
Exactly.
so the student must be know about the Sentinel data. They has to learn first, and if they have an experience, they will get the benefit. I think they will be more uh, interest to use the satellite imagery data, especially the SAR data, for their analysis in the future.
Yeah.
Okay, Bu Yayu, maybe you can explain to us the beneficial of Sentinel data to conduct any further research. In example, to correlate the decrease of carbon stock in urban area to the thermal comfort and the potential of greenhouse gas effect in the future. Maybe, Bu Yayu, because your research is very interesting.
Okay, thank you, for the time. Okay, for me is maybe I can maybe I think when identify detective, yeah, the detection land cover is important, and no, yeah, because land cover monitoring is essential to help ensure that sustainable regional development can be achieved, yeah. Okay, from remote sensing image, or we use to detect land cover change. Detects land cover change not only for surface carbon detection, but also for disaster mitigation. Like several area in our country experience flood Some of which are related to forest damage, yeah, or deforestry. Okay, maybe I think enough, Pak Widjonarko. Thank you.
Yeah, you for your short explanation. I think all of students must be know deeper about the satellite imagery and remote sensing technology, so they will get beneficial using the satellite imagery data for their research in the future. And using satellite imagery is very, very beneficial. First, we can we can save our time to get the data, and then we can save our money to obtain the data, and we can use many tools that has been produced by any software, ArcGIS as an example, or Quantum GIS or Snap that produced by ESA to process satellite imagery and to get more information about the Earth surface by generating the data from any satellite imagery, optical base or SAR base. Thank you. Maybe there is no question. I will give the time to Miss M.Si, Mbak Nikmah.
Thank you, Pak Koko.
Okay. Okay, Pak Koko, thank you so much for as a moderator for today. And before we conclude this lecture today, I would like to take a moment to thank all of our distinguished speaker for their valuable insight and expertise that they have shared with us today. And dear participants, we have come to the end of this enlightening and informative lecture. I hope you all have enjoyed and benefit from the presentation and discussion of our distinguished speakers. And I would like to thank them once again for their valuable contribution. We greatly appreciate your time to be here with us today. And the next is for documentation purpose. I invite all participants to open the camera and we will have a photo session. And I will take the screenshot from here, so I will wait until the participants will open the camera. Wait.
Great to see people's faces.
Maybe Bulani can help us for take a screenshot. Okay, I will count. Okay, maybe the other participants, do you want to join with us to open the camera?
I think they are shy, Mbak Nikmah.
Yes.
Okay, is this enough for the picture?
Okay, I will count from here. Oh,
Yeah, maybe we can, yeah.
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 Okay.
More comings, yeah. Good to see them.
Okay.
Okay, it's ready.
Done.
I will take a screenshot. 1, 2, and 3. Okay, maybe next slide.
Okay.
Okay. Once again, 1, 2, and 3. Okay. Thank you so much.
Yeah, that's
Thank
our
you, Mbak
pleasure.
Nikmah. Thank you, Pak
Mbak
Mustafa, for your
Nikmah.
sharing
Thank you.
Yeah, that's my
information and
pleasure.
your insight
Thank you,
on
Mustafa.
SAR data.
Thank you,
Yeah, thank you so
Mustafa.
much.
Thank you, Bu Yayu,
Yeah.
for your presentation and your research
Thank you,
on
Bang.
carbon stock.
Yeah, I will be,
Terima
yeah.
kasih. Thank you.
See you next time.
Yeah, see you.
Okay.
See you.
Thank you so much. Or maybe for those who like to hear this international lecture series again, the participant kindly check our YouTube channel at PK Undip TV Official. Thank you so much. I hope you all have a good day. Thank you.
Thank you.
Thank you.
See you all.
See you then.
Yeah.
Yeah.
Many thanks, Mustafa. Yeah.
Yeah, that's
So
my
happy.
pleasure.
Yeah, to see you again. Yeah, maybe next year lah. We
Yeah,
can create
exactly. So
collaboration. Yeah.
I'm always ready